Good morning, all of you. Welcome to One Mark Solution. Please subscribe, like, and share to all of your friends. Now, let us start with Assertion and Reason for the chapter 11. And the topic name also, you know that human eye and the colorful world. So let us start with Assertion and Reason, the first one. So again, I am telling, please go through the theory first of all, then only you can answer any question, not only assertion and reason, any question regarding that. And it is 1 mark question, isn't it? So you should be very careful. If you are writing the correct answer, you will get 1 mark. Otherwise, you won't get any mark. Just like the descriptive papers. If it is descriptive question and answers, if you are writing anything, what is it, depending on that question, you will get half mark. But it is not like that here. So you should be very careful. So please study the theory thoroughly, then we can go for that. So first of all, let us start with assertion. Blue color of the sky appears due to scattering of blue color. No doubt. Actually, due to the scattering only, we are getting the sky. That means we are getting the color of the sky as blue. Why it is like that? You know that Rayleigh's scattering of light. That is, Rayleigh's scattering of light is directly proportional to, that is, intensity of this light is directly proportional to 1 by lambda raised to 4. That is, inversely proportional to the 4th square of the wavelength. That means when wavelength increases, scattering will be less. And in the VIBGYOR, you know that VIBGYOR, out of that, these colors, which one is having more wavelength? Red is having more wavelength. So the scattering will be less. So which is having, we can say, less wavelength? Violet, indigo, blue. So that is why the bluish color, it is actually violet, indigo, blue comes together, and we can say bluish color will be appears in the sky. We can say due to scattering of the light. The reason, so absolutely correct, the first reason is correct. Blue color has shortest wavelength in the visible spectrum. Blue is shortest, we can say, that means VIBGYOR. Out of the VIBGYOR, we can say violet, indigo, blue are the shortest. So what is the answer? Both assertion and reason is correct, and reason is the correct explanation of the assertion. One more thing you have to see, that scattering depends on the wavelength. That means it is inversely proportional to the wavelength. Now, here the answer is option A. Now we can go for the second one. Second one, we can say hypermetropia is a defect of the eye. So many defects are there, isn't it? Myopia, that means short sight, long sight, like that. Usually the hypermetropia will be for old age people. Very rarely it will come for young people. It is a defect of the eye in which only farther objects are seen. That means our least distant of vision, the length is 25 centimeter. All of you know that, isn't it? If there is no defect, if you are placing 25 centimeter distance the object, it will be clear to you. Our eye, you know, isn't it? They will adjust the focal length and all, right? So here it is a defect of the eye. We can say that only farther object, that this person cannot be seen, that the object which is placed at 25 centimeter, that is a defect. Okay, what is the reason here? Hypermetropia is corrected by the converging lens. Is it the reason for that? No, it is not the reason, but we can say the reason is also correct. Why? Because it is corrected. How you are correcting? Actually using converging lens, isn't it? That means convex lens. You can, what is it, corrected if you are putting, what is it, the lens, that means the spectacles, using convex lens, we can see the image clearly. That means objects clearly. Okay, so here what is the answer? The option is B. That means assertion and reason is correct, but not the correct explanation for the assertion. Now we can go for the next one. The focal length of the objective lens of the telescope is larger than that of the eyepiece. Objective means what is it? Which is placed near to the object. What is eyepiece? Where we are seeing. So all of you know that telescope is having two lenses, isn't it? One is objective and one is eyepiece. Usually we will have, what is it? Larger focal length for objective. So assertion is absolutely correct. Now, what is the reason here? We will see that the resolving power of the telescope increases when the aperture of the object lens is small. Not at all. Why? Because if the aperture is large, then only the resolving power will be more. So what is the answer? We can say assertion is correct, but the reason is absolutely false. Okay, if the answer is like that, it increases with the increase of the aperture, then it would be the correct. So here the answer is option C, A is true and R is false. Now let us move on to the fourth one. That is, light from a distant object arriving at the eye lens may get converged at a point in front of the retina. Yes. Now, the eye is produced too much divergence in the incident beam. All of you know about the human eye, isn't it? So the first one is absolutely true, no doubt at all, isn't it? It should be in front of the antenna. But the reason eye is producing too much divergence, is it okay? No. If it is too much divergence, we won't get the correct image. So the reason is false. So which is the answer? The option is C. A is true, but R is false. Now we can go for the next one. You're studying human eye, isn't it? In biology also. So please study thoroughly about the human eye. You should know that we are using our eye, isn't it? Now let us move on to the next one. Light of violet color deviates the most and the light of red color the least when it is passing through the prism. You are studying under the heading refraction through a prism, isn't it? So what will happen when light is entering into one side of the prism? What is happening? It will, yes, deviate like that. And we can say we will get the spectrum, the dispersion, the process of dispersion takes place. When light is, what is it, split into 7 colors, we will call it as dispersion. So when it is passing through the prism, it will, the process dispersion also takes place. Then why we can see the 7 colors? Because of the deviation. And the deviation depends on the wavelength also. That is why here we can say violet color deviates the most and the red color least. Why? The deviation depends on the wavelength, means if the wavelength increases, the red is having largest wavelength, you know that, isn't it? So if the wavelength increases, the deviation will be least. So the assertion is absolutely correct. We will see the reason. For a prism material, refractive index is the highest for red light and lowest for the violet. Is it so? The reason is correct. But can we say this is the reason for the assertion? No. Reason is the deviation and the relation between the deviation and the wavelength. So here we can say both assertion and reason are true, but the reason is not the correct explanation of assertion. Now the option is B. We'll go for the next. The sixth assertion and reason. Secondary rainbow is fainter than primary rainbow. What is primary rainbow, we can say? What will happen there? You can say due to refraction and total internal reflection, isn't it? So secondary rainbow means, what is it? After, again, one more process takes place there. So total 3 process takes place. So after 3 process, when it comes to our eye, it will be fainter. And the order is also different. We will say Vibjor and this will be in the reverse order also. So that keep in mind what is the difference between primary and the secondary rainbow. So assertion is absolutely correct. What about reason? Secondary rainbow formation is 3-step process. I told that. And hence the intensity of the light is reduced at the second reflection inside the raindrop. So which will be the answer here? No doubt both assertion and reason are true. But and reason we can say it's a correct explanation of the assertion. Right? The intensity will be reduced. That is why we can say it's fainter. Right? So the answer is absolutely correct. What is it? A. Now let us move on to the next one. Assertion. A normal human eye can clearly see all the objects beyond certain minimum distance. Yes. Is it correct? You just think it of, just read it out. Okay. Next one, reason. The human eye has capacity of adjusting the focal length of the eye lens. Yes, of course. That is why we are seeing all the objects, isn't it? Whatever be the distance, right? So now we can say that what is the minimum distance name? Just now we told that it is the least distance of distant vision. It is 25 centimeter. I'm repeating why, because you should know that. Right? So here both assertion and reason are true, but we can say the reason is the correct explanation. So which is the answer? Option A. Very simple one. Now, a rainbow, again rainbow, is sometimes seen in the sky in rainy season only when observer's back is towards the sun, isn't it? Observer back, where is it? Towards the sun. Then only rainbow is sometimes in the sky. Then, what is the reason? Internal reflection, the water droplets cause dispersion and final rays are in the backward direction. It is not, it is actually, we can call it as total internal reflection. You know the process total internal reflection, isn't it? If the angle of incidence is more than critical angle, it will be reflected back to the same medium. So that is why the total internal reflection in the water droplets cause dispersion. Dispersion means it is split into different colors, and the final rays in the backward direction. That is why we want to, where we have to stand just like that, observers back towards the sun. So we will get the rainbow now. So here the answer is very simple. A and R are 2. That means assertion and reason are 2. And the reason is the correct explanation of A. And now we can go for the next one. Twinkling of stars. What do you mean by twinkling? You know that, isn't it? Is due to the fact that refractive index of the Earth's atmosphere fluctuates, right? In cold countries, the phenomenon, that is correct only, twinkling of stars. Because of the Earth, why it is fluctuating, we can say, depends on the, the content, and depends on the, temperature also. It will be different. In cold countries, the phenomenon of looming, you know what you mean by phenomenon of looming, isn't it? Example also here given. The shape appears in the sky. Is it possible? Only because of the illusion, right? That is of the loom. Takes place because refractive index of air decreases with the height. So, but here we can say the reason and assertion given is absolutely true. But can we say it is due to the twinkling of stars is due to this reason? Reason here given is looming. So here we can say reason is not the correct explanation of the assertion. Now we can go for the next one, the 10th question. The sky looks dark and black instead of blue in outer space. Why it is like that? You can think it of. Dark and black. Why? In outer space, anything is there? Any atmosphere is there? No. So, it looks, dark and black. What is the reason we can say? No atmosphere containing air in the outer space to scatter sunlight. That is why it looks dark and black instead of the blue in the outer space. And this is very simple, you know that, isn't it? If there is atmosphere, then only it will scattering. Scattering means it will reaches and it is scattering. What will happen? The intensity of the light depends on the wavelength also. You know that. It should scatter. How it is scattering? It should incident on the dust particles and we have to reflect it back. So it is not there. No atmosphere is there. So how will you get it? Any color you will get it? No. So that is why it appears dark only in the outer space. Now we will conclude for that. So please, again I'm telling, please study the concept clearly. You will get an answer very clear. Thank you for watching.